Thanks for joining me. I'm really excited about this session because it allowed me to kind of revisit my past a little bit and explore some of the use cases where I was a part of the development of machine learning and AI technologies. But before I start, wanted to just say thank you to the attendees and crew. Organizing these things is very difficult, and I know that anybody who's ever done it ends the day just totally exhausted. So I appreciate the efforts there and the logistics, because I know I couldn't do it myself. So I think it's always important to start off with kind of a credibility slide. Why do I think that I'm qualified to be up here and talk to you today about AI and machine learning? And so I'm going to give you just a brief history on who I am. My name is Chris Riley. My title is Dev Advocate for Splunk. If you've encountered advocates before, you know that it's a very unique role where you kind of cross multiple functions within the organization and you engage with practitioners out in the field. But it also sort of means what I say all the time is I'm a bad coder turned advocate, which is largely true. I know how to develop. But the business of and the practice of development kind of always eluded me to some extent, and it came down to details. I started my career out as an IT pro in Colorado, and during that time is when I started building a genetic algorithms startup, and it was genetic algorithms SDK, very heavily invested in that technology and concept, and I'll come back to that in a second. And that's when I bridged from being an IT professional into application development. Made my way to the Silicon Valley and chased the Silicon Valley dream for a while as a developer. And then quickly found out that my aptitude was more geared towards talking about development and exploring how people are embracing modern development practices versus being a heads down developer myself. And so that's where I am today. That QR code will get you to all my social things if you're interested. And I'll put it back up at the very end. And it is scannable. I've been playing around with changing the colors and it stays scannable. It's amazing. So the point of this session, it's titled Getting Real About AI and Machine Learning. All of us techies are really good, healthy curmudgeons, which means that a lot of times when we hear the word AI or AI ops or machine learning or whatever it is, we may tend to roll our eyes. And I know I'm guilty of that as well. And the thing is that a lot of times what we call AI is actually machine learning. And a lot of times what we call machine learning is actually statistics. And, the marketing folks out there are really good at building excitement around these technologies, which are all very real. But it's important when you start thinking about how you're going to implement machine learning and AI in your application, how to be a little bit more grounded about it. Because without being grounded, you can get yourself in trouble. And I have countless examples of that out in the field, but also just with my experience in building these types of applications. So a little bit different than the other sessions you've seen today, like the previous one on Anvil, where it's going to be less focused on specific frameworks and implementations, but more focused on strategy and approach. And it's really targeted at developers, 50% developers and 50% data scientists. So developers who are responsible for deploying machine learning models, and then data scientists who build those models and want to understand better about how to get them out the door and be more successful with them. So really, it's all about bringing that AI machine learning functionality into reality, looking at some of the technical challenges, and then going over some recommended best practices. Now, like I said, a lot of times when we say AI, it's fairy dust, and we're throwing fairy dust in people's faces. And it's important to be precise when we talk about implementing this stuff, because I think we're all guilty of that. We all as techies want to be on the cutting edge and focus on the new. But all that really matters is how this functionality impacts our users at the end of the day and the benefits that it brings them. Now, I have a lot of respect for our CEO, Doug Merritt, and I especially was fond of this article that I found on my own, where he was interviewed talking about artificial intelligence and what that means in the real world. Because even at Splunk, we talk about machine learning and artificial intelligence in the form of what we call AI ops quite a bit, and what it actually means. And in this article, there's a quote saying that artificial intelligence doesn't exist today, but it's really referring to it from the perspective of, truly autonomous beings that think on their own, and their logic is been generated, autonomously. But most of what we talk about when we talk about AI and machine learning is we're talking about the technology that helps users do their job better or helps them skip the remedial stuff. And it's all about empowering doing. And really, what I want to talk about today is the grounded aspects of that and how we bring that into our applications in a meaningful way. Now, the first thing is obviously we're at a Python conference. And one of the questions I always ask myself is, why is Python used so much for machine learning? And I keep on hunting for this magical answer that Python does X better than any other language specifically for machine learning, either building models or executing them. I haven't found that. If anybody knows what that is, let me know. What I did discover is a lot of it was grounded in luck and community. So Python is a very stable language. It's accepted as a stable language. The timing was good. So when I was involved in building artificial intelligence and machine learning, at that time, it wasn't very accessible. Around the same time that machine learning became more accessible and more embraced as companies saw the business value of bringing it into their applications, is around the same time that Python became more popular as a language. So timing was really good. But also the syntax of Python lends itself very well to new developers. So people who are technical but getting into application development. And it's friendly for the data scientist. Conversely, I've been working recently with TypeScript and Node, and there's a lot of languages out there that have syntax that is very wonky and confusing, and Python does a better job at making that friendly. The other thing is there are options for increased performance for more complex models in the form of bindings in C and C++. And then finally, along with the community, there's a large number of frameworks and libraries available. And the most popular, PyTorch and Scikit, that make it a lot easier to jump in and just start using the language for machine learning, model building, and execution. But in addition to that, and just broadly in the market overall, is a huge collection of vendor tooling that makes it easier for you to take these models and run them, but also run your experiments and track your experiments and learn from them. And so in addition to Splunk, who's one vendor who has it, JetBrains, who's a sponsor of this event, other vendors out there that just make it a lot easier to build and deploy machine learning technologies into your application. But sometimes it's also too easy. And that's where, the accessibility of machine learning has become tremendous. Deploying it is also become tremendous. The problem that we're seeing is the same problem that we saw in the early days of DevOps. So when DevOps first came to be, it was largely a conversation around culture. Then a whole bunch of tooling came out that made it easier to deploy your applications faster. Now what we're seeing is that velocity created a whole bunch of new challenges, and the technology and the tooling come out are on the management plane of DevOps. So we're going to see the same in machine learning. We're still in the early days of where we've accelerated the adoption and the ability to build this intelligence into your application. But now we're creating new challenges. And those challenges are around building intelligence in a very sustainable way. What does that mean? Well, the amazing thing about machine learning is that you can get a wow factor very quickly. And it's tremendous, that feeling of building a model that works. It works really well, not only on your truth data, but also on new data is super exciting. And it's very easy to lose sight of the fact that that model has to last for a very long period of time in a lot of very diverse scenarios. And that's sustainability, is can it do that? So it's the grown-up part of this that is challenging. Also, part of the grown-up part is it manageable? So within your organization, do you have data scientists who, if they happen to leave the organization, take all the knowledge with them? And now you can't even support the models that you've deployed, but you can't just get rid of them because your users have started to rely on that functionality. So is building this functionality into your application sustainable and manageable over a long period of time? And then at the end of the day, we need to be supporting the business, right? If it doesn't generate new revenue or save money, it's you're not going to get anywhere, and there's no long-term life to that. Even though I wish that we could play with, especially in my early days of genetic algorithms, I wish I could just play with the technology all day long and not worry about the financial aspects of it. But eventually I had to get paid, and that was the end of my genetic algorithms career. So sustainable, manageable, and does it support the business are all very important considerations when building this type of intelligence into your application. And that's really what I want to impart and uncover here today. So now I'm going to do that by going through specifically my history as it relates to building this type of functionality. And machine learning and AI has touched my technical career in 4 different places. First is when I had the startup where I was building an SDK for genetic algorithms. If you're not familiar with genetic algorithms, it's this really cool approach to solving problems where you essentially build populations of critters that start out with no logic to them. Now, critters can have neural network brains, or they can have no brains at all. They can literally just be a string of binary characters that serve zero purpose. What you do with the critters is you build fitness functions. So that would be the equivalent of your truth data in most machine learning models. And you continuously evolve and evaluate the critters against these fitness functions. How they perform is how likely they are to breed and reproduce. And you do this at computer speed. So it's really cool because it becomes a very awesome tool for solving very complex problems. The challenge with genetic algorithms is not in the core processing or the running evolutions and generations. It's creating the fitness function, and also the fact that most of the time, genetic algorithms are an over-engineering of problems that have much simpler answers. And that was the death of my startup. Because while genetic algorithms are really cool, it's a solution to a very small subset of problems that can't be solved in other ways. And just by simple statistics, now with machine learning, simulated annealing very often can be used in replace of genetic algorithms. And that was a big lesson to me. It resulted in me dissolving a business and going and becoming a developer in the area of optical character recognition. The next three phases were in the area of OCR, which is optical character recognition, natural language processing, and then now with my involvement in Splunk and the things that Splunk has built, leveraging machine learning and artificial intelligence. So I'm going to go through each of these, but here's the punchline. In the days of document recognition, I learned that models have long-term consequences. And while it may be easy to create a model today, the extensibility of that model has to be considered. And without considering that, then it can invalidate the model down the road. And I'll explain a little bit more why. When I was part of building an NLP application, natural language processing, I learned that data scientists need to think like developers. And then now at Splunk, one of the big things that I'm learning is on the go-to-market side, which is when you talk to customers about the technology that you've built in the application, talk about the outcome, not the fairy dust. So what I like, you may not be building OCR applications today, and that's fine. The reason it's good to look at kind of older machine learning and AI technologies is because the lessons learned in those industries are 100% valid today. They may have been applications built in a monolithic way pre-Python, but the lessons learned haven't changed. And a lot of the ways those technologies are used, which are still used today, of course, are applicable to models that are built today and their future. So it's kind of a way to look at history to kind of predict the future. Now, in the area of document recognition, there's a lot of core technologies, and they're all different. Some of them are neural net based. A lot of them aren't. A lot of them are more kind of histogram comparisons and so forth. In the category of document recognition, you have IDR, which is intelligent document recognition, which is the ability to capture a document and tell you whether it's an invoice or a EOB or a letter or some other type of document. So it's document level, not character level. OCR is optical character recognition, which is character and word level. ICR is handprint recognition when you fill out a form. There's another variation of this, which is handwritten, which I would argue is not a reasonable problem to go and solve with machine learning. And then OMR is also forms when you fill out a bubble. So like I said, they're all different. They have different challenges. And what most of us know today is optical character recognition. Now, optical character recognition, one of the crazy things that I learned, the first thing is that still today, the core recognition algorithms, the neural nets that do the basic recognition of characters based on the connected components algorithm have been largely untouched. Now, the reason they've been untouched is one of the things that I said before. The people who created them from the early days of Ray Kurzweil, when the first OCR engine was created, are no longer involved in building this technology. So they were built, the algorithms were built, they were compiled, and now they've been widely used for a very long period of time. In the industry, there's really only two players that produce core recognition technology and are working to improve these. But the old legacy engines are still widely leveraged. One of them is called TextBridge, and there's the original CARE engine, and so forth. And that's pretty amazing because if you think about it, these are technologies that we don't consider trivial. Robots are using OCR now to read things. When OCR was originally created, it was around accessibility and being able to scan documents and convert them into text. but the applications now bleed into robotics and others down the road. So it's not like this technology is going away, but the core of it hasn't changed. And it hasn't changed because it can't be changed. Nobody understands how it works anymore. The experts have left the room. Now, how OCR is improved has all been by abstractions. So you have the core recognition technology, which hasn't really changed. Layered on top of that was the addition of dictionaries. That was the next big evolution, where instead of looking at characters, you looked at words, and you used statistics to decide how likely a character was a character based on dictionaries. So these large systems of experts were created to make OCR better because they couldn't change the core underlying algorithms. The other thing that was quite amazing, and it continues to change, is that the nature of the data changed dramatically. So this is something that you, as the person building the model, don't have a lot of control over. You know what your truth data is today. You can kind of anticipate what is going to be in the future. But in the area of OCR specifically, nobody really knew what was going to happen. And basically what that was is that there was this evolution of high quality document scanners that came out that produced really high quality images. Then faxes ruined everything. So faxes were super convenient. They were fast, but the image quality was horrendous. So the OCR engines were built and trained on high quality images, now had to be adapted to low resolution, 96 DPI type images, maybe even less, and had to try to recognize that because fax adoption was tremendous. Fast forward to now, we even have higher quality images. So not just from document scanners, but from photographs. I use several apps on my phone on a regular basis to OCR documents. And what that's done is it's gone from the black and white recognition technologies into the possibility of now using depth and colors in the recognition technologies. So in the OCR, new experts had to be added to these engines to support that and leverage that. So it's been quite amazing. And it really impacted the models, and the OCR vendors in each of these major stages where the truth data started to evolve had to reshuffle and make adaptations and new abstractions to address it. The other thing that I learned is during implementation, users spent a significant amount of time going from 95% accuracy to 97% accuracy. And it was a colossal waste of time. They were mistakenly investing in incremental fractional gains in the algorithms that didn't tie to the business. And then finally, I also learned that human in the loop and supervised OCR, even though it's not sexy and cool, was super effective. So that gets to kind of the gotchas that I learned from the OCR industry, which is defects in your algorithms can grow exponentially. Something that might seem minuscule today in your model as a problem that you can easily overlook because it's, tenths of a percent difference, can become very large later on as data sets change and so forth. The other thing is that biases are extremely easy. You can almost assume that biases are going to be introduced into your early models, and you have to take that into consideration. Next is that with some applications like OCR, false positives can make or break the functionality and the viability of your model. And you have to understand that from a business perspective to decide if that's true or not. It doesn't mean that you stop what you're doing. It means that you are reasonable about the impact of false positives, because if you're not, it can be the death of a model. The other thing is that, like with genetic algorithms, while complexity in your models can seem really exciting and fun, it can be very costly and more costly than beneficial down the road. So if you're fans of the Silicon Valley, I have three kind of fun examples of this. In Silicon Valley, there was a application built for not hot dog, which is take a picture of something, identify whether it's a hot dog or not hot dog. If you've seen this, you know where this goes. If you haven't seen it, it's worth watching because it's hilarious. The problem with this particular model that they developed is that it was only trained, well, first it was trained to identify if something wasn't a hot dog, and the truth data set was only hot dogs. So this is where it's very easy to introduce biases in your models if your classes are not well diversified. Another example that's very recent is the bug that came out in the face identification from iOS, where it wouldn't authenticate the device if you had a mask on. And I thought it was really cool how Apple addressed this. They did it very intelligently, and they were very realistic about it. So instead of trying to update their model for facial recognition to support face masks, which would have been maybe the more exciting approach, instead what they did is just made the passcode screen come up sooner instead of trying to identify the face with the mask. So it's not the most attractive approach, but it's the most logical one, because to retrain your model with face masks could introduce a whole slew of new problems, even though that might seem like the most interesting way to go. Another example from recent times, because there's been a lot of cool stuff that came out of this, and I can share all the links that I have here on Slack afterwards, is the fact that some of the pandemic models out there, a lot of them failed with the current pandemic because there were so many elements that just didn't make sense. Our behavior, the way it spread, etc. And even though at the time these models seemed not foolproof, because there is no such thing as foolproof when we talk about these types of technologies, but they seemed stable and they seemed powerful, but they weren't, because the behaviors were completely unanticipated when the model was created. So now I want to talk about a little bit about natural language processing in my days there. And I learned when I was a part of building an NLP toolkit, one of the things that's really interesting is NLP largely is not that different from OCR. You use a system of experts. A lot of times there's the core recognition technology that fundamentally doesn't really change, and you built on top of it with accuracy based on abstractions and other data sources. Wikipedia, for example, can be used to improve NLP technology. But what I learned in these days was that how important the way models were developed and the way they were launched were. So I worked with a lot of data scientists. They like to write a lot of academic papers as part of the research of building their models. And they were very academically focused, brilliant people. But when it came to deploying their models in the application that was released to businesses as a bundled application, the developers who were deploying it were disconnected. They were lost. They didn't understand what they were doing with the algorithms they were given necessarily. And the data scientists didn't understand how that was all going to come together in the application, nor did they really care. The other thing is that the go-to-market, how it was launched, was largely focused on the academic aspects, which was how good is the NLP that we're using versus how are you user going to leverage it. So it was both a problem of development and go-to-market. And on the development side, I realized that spending 90% of your time on the model creation and only 10% of the time on development is just not effective. It doesn't relate to being manageable and sustainable. And how you get your models out the door matters a lot. So this is a very recent article that I just happened across because of a coworker, and it's a very interesting read on just that. Do your data scientists understand the business value of what they're building and bringing to the users? So on the go-to-market side, if they don't, then they're not really aligning with what the customers want. Because it's fun to talk about the technology. It's fun to explore all the intricacies of models and how you built them and how you're leveraging deep learning, because that sounds really cool. But all your customers care about is what it does, what the outcome is. And this was also true in OCR, is that when you oversell the intelligent capabilities in your product, you can actually slow down sales cycles and make it more difficult to sell, because your users are trying to understand. They want to understand. They think it's cool also. So they will dwell on it. But also because they dwell on it, and especially in OCR and NLP, this is true, their expectations are through the roof. You've misguided their expectations. They're expecting magic and fairy dust. When they don't get it, they get very angry. There's actually examples, many examples of lawsuits in the OCR field of exactly this, even though clearly no vendor has said that OCR is 100% accurate. The expectations sometimes are that. And so you have to be careful when you bring these to market, and it starts from the data scientists, believe it or not. So let's fast forward to now. Now, as I said, I am an advocate at Splunk, a developer advocate, largely focused in the areas of application development and DevOps. And that allows me to get exposed to our engineering teams. And of course, being a good former developer of some intelligent technologies, I get very interested in the things that we're doing around machine learning. So the areas where Splunk is leveraging, and if you're not familiar with Splunk, Splunk is a data analytics and visualization platform. So you can throw it a whole bunch of data and visualize it. We call ourselves the data to everything platform, and our job is to bring data to every decision, question, and action. The functionality we've built that leverages ML in the category of AI ops, which is a new industry term around technology that helps operations people do their job better. We have anomaly detection, as you would expect. We have what's called the ML toolkit, which allows you to build models based on data that you've brought into the platform. We also have auto remediation functionality, where you can automatically run scripts, runbooks, workbooks based on events and incidents that are triggered from the data. And then we have an incident response platform, which is a tool for those who are on call, help on call suck less, because nobody likes to be on call. And the functionality that we've used ML in there is a feature called recommended responders and similar incidents. So our recommended responders feature, what this does is it will, if you are on call, let's say you get an incident, you get paged at night, you look at it, you acknowledge it, and then you start to go through the details and you realize you're not the right person to be firefighting this. You need to bring in help. What the recommended responders feature does is allows you to add people to the incident who, based on previous incidents that they've responded to. So what we're doing is looking at a history of incidents and all the activity associated with that incident and the people involved, and correlating those together to say, hey, we think that these are people that you can bring into the firefight to help you. Some of the challenges around the model there is that there's a broad range of object types. You have people, you have metadata around the incidents, and then you have incident payloads, essentially. And all of those have different weights and you have to correlate them together. That means that the content also includes the workflow. So it doesn't just include the payload of the incident, it includes all the activity that leads up to resolution. Because if you don't include that, you don't have the full picture of how those individuals address the incident and were they truly part of the resolution. And in this world where events and alerts can be very noisy, that noise can have a large impact. So these are all challenges that our amazing data science team had to grapple with before they launched this functionality and when they were running experiments on the models they were building. The next one, similar incidents. Similar incidents is very similar. There is a broad range of object types. What is unique here is that in this scenario, like I was saying before, where you have to think about false positives and the impact of false positives, in this scenario, similar incidents are more sensitive to false positives. What that means is that the users, from the user perspective, a false positive is more impactful to what they're doing than with recommended responders. That's very important to know because, again, you are creating, the users have expectations in their minds of how this technology is going to work, and you need to meet those expectations. So it's been very fun to learn from our data science team how they went through these challenges. I can't share a lot of the answers to that, but we did, and we launched this functionality, and it has been, the uptick has been fantastic. So that is kind of my history and what has led to these final conclusions, which are the best practices that I'm going to cover here quickly because we're running out of time. So first of all, in the model, I've covered most of all of this, and some of it is silly obvious as well. First thing is, do not test your models on true sets or demo environments. Even if you have multiple sets of true sets, do not test your model on true sets. And like in the case of, the functionality we've deployed with recommended responders and similar incidents, demo environments. A lot of times organizations will have demo environments they use to demo their product to customers. Don't test your true sets in your model, or don't test your models on those environments. It may seem easy, but that data is not accurate at all. A lot of times, less complex models with larger true sets are better. One thing to consider is that you need to have a system of running your experiments on your models. So don't just think about the building of the model itself, think about how you build those models. Don't automate your initial true set. And what this means, and this is painful, you don't just run a script to pull down automate data and automatically label it. Really, for your initial true set, it needs to be a manual process, and you need to label it manually, because that is going to dramatically impact not both the quality of the model, but your understanding of how the model was created. Deep learning sounds really cool, is much more accessible than it used to be, but be timid about implementing deep learning technology from the get-go. Start with the basics. And then focus on quality. You need to have balanced classes. Metrics can lie to you, so be skeptical. And sometimes you need to think about leveraging expert systems and multiple models instead of just one monolithic model to solve all problems. On the development side, spend 90% on development and 10% on R&D. So flip it. Focus on development practices. Treat it like a software project, not a science project, which means partner with your product managers, leverage Agile and DevOps. Think about linting and testing and microservices architectures for your models, and feature flags, which are extremely powerful. And use your own product. That's the best way to understand your users' expectations. On the go-to-market side, this is fairly obvious. Sell the outcome, not the machine learning. Don't sell the magic, and don't overpromise. I know it's easy to want to talk about the tech, but it can be problematic when you launch the product. And you may be saying, I'm the developer. That's not my job. It's marketing's job. Marketing learns from you. Just always keep that in mind. It actually starts with the data scientists and developers. So I know I kind of rushed through those at the end, and I'm going to share the slides on Slack, but running out of time. Also, here's a whole bunch of links. I'd like to go to the QA instead of just putting these up. And I'm going to share these on Slack. They're projects that I've been really interested in lately, and some newsletters and resources and interesting articles that I've come across that I think are really cool. So thank you, everybody, for your time. I think we'll have a few minutes for question and answer with Josh, and then we'll bounce over to the gallery to have additional conversation if you're interested.
Fantastic. Thank you so much, Chris. I saw those resources you had up. Are those good resources for folks who are just starting out, who just kind of learn more about AI ML? Are those kind of just some interesting things?
So, well, the big one is The Incredible PyTorch is a fantastic set of tools, libraries, guides for somebody getting started. But there are also a lot of really interesting articles. Uber has what's called the Michelangelo Project. And what I like about the article that describes their project for machine learning is it covers everything I said in a nice, very bundled way, where they spend a lot of time thinking about how they're going to run their experiments and how they're going to deploy them. And so that's another article that I think is really useful. So it's news and resources. And I think probably what I'll do is just to do a data dump in the Track 3 Slack of all of these, and you can click through them.
Yeah. Another question I guess I have is, how tech savvy do you think someone has to be get the most out of Splunk?
Oh, Splunk specifically. Oh, man. Not a lot.
AI ML savvy specifically.
Yeah. So for ML specific, what's cool is taking a model and running it. If you're a developer, you can do that with the modern technology out there. Building models, because of the implications and the biases you can introduce into a model that have long-term consequences, you need to have a very healthy understanding of data structures, machine learning, neural nets, and that sort of stuff. So it is definitely a technical thing, but it shouldn't be considered a barrier to entry because there's so much out there to learn. I'm happy to have conversations about that kind of stuff because I absolutely love it. My degree is not in machine learning, it's in computer science, but I got very heavily involved in it. As it relates to Splunk, not a lot. If you know how to run a Docker container, you can start using Splunk today. On Docker Hub, there's Splunk/Splunk. You can spin up a container and start throwing data at it within an hour. And that's usually how I play with it. I just started using this habit tracking app. And today I was messing around with storing that data and analyzing that. So that's kind of fun.